All right, last page of 7.1. I know it was a long lesson, but we worked really hard to get to this point. This you are going to be using as we move forward. It's used in the discussion, one of them, if it's still there, and percent increase, percent decrease, how much is something changed? Um, right here is a good formula to keep somewhere. It's the difference. It's the percentage change in difference, okay, equals the original times the variable. The original, if it's going up, um, we're just going to use a positive change, and it went, um, let's see, I made some notes on this just to see if I could make it sound a little simpler. For an increase, if it went up, the original number is smaller. Okay, that makes sense, right? If it went down, there's a reduction, and the original number is the larger number. So just be careful as you're going forward. But this is the kind of the general formula for a percent change. Okay, so for example, if the original pair of shoes was $49.99 and they were marked down, so that's a reduction in price. So find the difference in them. That's $17.50 off. Okay. Um, for $17.50 off, what percent of that was that? Okay. When you say what percent of, you're multiplying. I throw in a variable in there. Okay. So you end up solving for whatever the difference is divided by the original times. So this is, here, let me write this down. 1750 is the difference, okay? Equals the original times, the original, which was the original price of the shoes that went down. So that's the original, times a variable. I usually use P for price. To get this P alone, you're dividing by what's next to it to get the P alone on one side. So here you're also dividing by the same thing, and you're going to get this little decimal right here. Okay. To turn this decimal into percent, you're moving it two places to the right or multiplying it by 100 and putting a percentage sign after it. Okay. So that is a price reduction. So you take, this is what I was talking about, you take the higher price and put it next to the P. Okay. Because the difference is always on this side. So here's another one. 20 hours this week, 35 hours next week. That's an increase. How much more did she work? You still need the difference. Make that a positive number, okay? Whatever it takes. 15 is what percent of 20 is one way to think about it, but the difference goes on one side, okay? And then the original amount in this case is the smaller number because that's what it was to start with that went up, okay? So that goes here. We're going to divide both sides by 20. 15 divided by 20 is 0.75 times 100, moves decimal two places to the right. Throw the percentage next to it. I mean, this makes sense because if you doubled your hours, if you had a 100% increase, you would have 40 hours. Okay, so 75 is what 35 comes out to. That makes sense. Make sure your results make sense. All right. Last ones here. All right, the price was reduced from $109.99 to $99.99. $10 difference. And it was reduced, so the original price was that. We want to find the percent reduction in price. So the original price times the variable divided by whatever's in front of the variable to make it go away. Isolate your P alone on one side, and whatever you do to one side, you do the other side. And this number is going to come out to 0.0909 9, and a whole bunch of other stuff. We want to multiply it by 100 to get a percent from a decimal. So that's going to be approximately 9.1 or 9%, depending on what they want you to round it to. Okay, of a reduction in the price. So not a whole lot, but gets smaller. All right, number 2, we have a computer monitor is on sale for that. It was reduced $80 from the original price. That is the sale price. Find the reduction in price. It's the same as the amount discounted. So if $80 was taken off, if we put it back on, we will get the original price, so we can start to begin how much reduction it is. Okay, so the difference is obviously to the $80, and then the original price that it got reduced from was that. To get rid of it on that side, whatever we do to one side, we do the other side. Put that in your calculator. You get 0.24243 blah, 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 blah. Multiply times 100, and you get approximately 24% amount discounted, or a price reduction. Average teacher salary in the school went from this to this in 5 years. Find the increase. Percent increases, percent changes. Always start with the difference. And you always want a positive number. Find out how far apart these numbers are. Put that on the first side of the equation. And then remember, it went from this to this. So the original was the smaller number in this case. That goes next to your variable. Make it go away. Remember, these aren't periods, these are commas. I just do that to make sure I get all the numbers in there. All right, that gets my P alone on one side, and we get 0.0845, blah, 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 blah. So we want to multiply by 100 to get approximately 8.5, right? 1, 2 goes here. If I just randomly decided to round it to 1 decimal, it would be 8.5. If it wanted the whole number, it could also be 8, because you'd be looking at the 4, and the decimal will be here. So the nearest whole number would be here. Also accepted would be 8.45. So it depends where you round, but all of these are rounded properly. You may not put 9 as an answer. You may not put something that isn't rounded properly. Okay, Alex usually tells you what they want.